Hello friends, welcome to Shiksharthi. In this video, we'll be talking about the roots of a quadratic equation. So let's start. So if you have seen my earlier videos in which we have already talked about quadratic expression, factors, various types of quadratic equation, expressions and then equations. So I am not going to talk about various types of quadratic equations because the entire discussion that we have done in the earlier videos on quadratic expressions can be converted into quadratic equations, which we have discussed in the video itself. Okay, so taking forward from my last video, we had talked about the zeros of a quadratic equation, and we discussed the moment this quadratic equation, which is of the form, let's say this quadratic expression which is of the form ax square plus bx plus c is equated to a zero, it is then we call it as a quadratic equation. And then we talk about the zeros. Now why do we talk about the zeros? Because here we have equated it to a zero. So the moment you write it like this and then eventually, so the basic condition here is a should not be equal to a zero. And as you're already aware of the fact that a, b, c, x are basically, what is a, b, c here? A, b, c are constant terms, or in other terms we can define them as coefficients of various powers of x. What is x here? A variable, right? And how many powers of x are possible in a quadratic equation? 3 different powers of x are possible, and those powers would vary from x to the power 0 to x to the power 2. Which is why in a standard form of a quadratic equation, mark the words being used, standard form of a quadratic equation, you will always have 3 terms. 1, 2, 3. Right? So anyway, so we had derived something like, we can write this as a times of x minus so this we had derived it in the expression form. Now I'm writing it in the equation format. So the moment the expression is equated to a zero, then we talk about the zeros of this quadratic equation, and these are the zeros. So these are the zeros means, let us say this value is alpha and this value is beta. So I can write down the same expression as a times of x minus alpha into x minus beta becomes equal to a 0, where alpha or beta are the roots or the zeros. So mark the words being used. Now why am I using a word like or? Now we know that if I am writing a cross b equal to a 0, then at a time you have only one component equal to a 0. So if you are saying a times of x minus alpha into x minus beta is equal to a 0, in that case you will say that a times of, so let's put it like this, one of them will be a non-zero term, because 0 into 0 is not equal to a 0. It is 0 into a non-zero term which is equal to a 0. Right? So when you say x is not equal to alpha, then you would say a times of x minus beta is equal to a 0, which means the root here is x is equal to beta. Now this is a standalone term. Or you say, or another condition is, if x is not equal to a beta, then we say a times of x minus alpha is equal to a 0. Now we know that a itself is a non-zero number. A can take any number value which is either real or complex, but it cannot be a 0. So now in this case you will say the other root is, or the other 0 is, x is equal to alpha, which is why this terminology is very important. Now why are we talking about this terminology? Because sometimes you are asked oral questions, sometimes you are asked questions in different formats, you are writing different type of tests, maybe board exams, a competitive exam or whatsoever, right? So in that case, one should be attentive of the words which we are using. So we will always say that a quadratic equation will have two roots. That is okay. So that is a total of two roots. But in that case, one root is alpha and the other root is beta. That's correct when you're saying and. But when you're writing the roots, you'll write the roots as alpha or beta are the roots. Is the language that you're going to write when you're talking about the roots or the zeros of a quadratic equation. Having said this, the next thing that I would like to talk about here is, now we know that delta is the discriminant, which we had already talked about. So this discriminant decides the nature of the roots. This discriminant decides the nature of the roots. And why does it decide the nature of the roots? The reason here is because there is an under root here. So under root, the value of the under root decides whether it is a real value or it is not a real value, which is why the only deciding factor in terms of the nature of the roots is delta. There is nothing else which decides the nature of the roots. We'll talk about delta in few minutes, maybe not, if not in this video, in the other video. Okay. Now the point here is, when I have roots and I know that, so now some element of logic here. So we are talking about roots or the zeros of a quadratic equation. We are talking about the zeros or the roots of a quadratic equation. In that case, we already have the roots with us. So there could be only two conditions, and we know that there are two roots. And the roots are alpha or beta. Alpha or beta. So there is one case which I can make here, and the other case. One case here is alpha is not equal to beta, and the other case is alpha is equal to a beta. So here we are talking about unequal roots, and here we are talking about equal roots. Why are we doing this? Maybe we are trying to establish the role of delta in deciding the nature of the roots. Okay, so now when we are saying alpha is equal to beta, let us just pick up the values from here. Let us just see that, okay, alpha is minus b minus root delta upon 2a, and beta is minus b plus root delta upon 2a. Right? And a, already we know that a is a non-zero number value. A takes a non-zero number value. We already know this in advance. Now the next thing that you're supposed to do here is, we know that this gets cancelled out. So eventually you will say what? Now this goes on the other hand side. So you will say twice of root of delta upon twice of a is equal to a 0. Then you would say that root of delta is equal to a 0, because now you are multiplying 0 with a non-zero term, which is a is non-zero. Now the moment you say root of delta is equal to 0, the inference here is delta is equal to 0. So this is how you get the condition for two equal roots. But as of now, we are not saying whether the roots are real. But the point that arises here is, and we are just using the element of logic or analytical reasoning here. Now if the roots are not real, in that case we do not talk about the polarity of the roots. Or let's put it like this, we talk about the polarity of the roots, but we do not talk about the magnitude of the roots. So at a time we talk about only one thing. I mean, what I intend to say here is, you talk about the roots being equal. When do we talk about the roots being equal? When we say that their measure is the same. So you talk about the measurement only for real numbers, not for imaginary or not for non-real. So which is why eventually this becomes a condition for real roots or real zeros. Right? Okay, now let's talk about the unequal part of it. So we will do the same, except for so what will we say? We will say the same. We will say twice of root of delta upon 2a should not be equal to a 0, and eventually you would say that root of delta should not be equal to a 0. which finally leads you to saying that delta should not be equal to a 0. Now when I say delta should not be equal to a 0, in this case we can make two cases. One case is delta is less than 0, and the other case is delta is greater than 0. So what we are saying basically is, if I take, so please understand it like this, what I am trying to say is, and I'll explain this with the help of an example. If I take root of delta, so if I say root of 4, and at the same time if I say root of minus 4 is what I am discussing. So in this case, when I am taking root of 4, I am assuming that there is no assumption now, this is delta is greater than 0. So in this case your answer will be plus 2. Your answer can never be negative, because square root of a real number can never give you a negative answer. So this again becomes a condition for real roots only, or real zeros. But then you know that real unequal roots. Now in this case, this is, when we are talking about real, this becomes what? This becomes a case for non-real. Why? Because under root of minus 4 will give me a non-real answer, and root of plus 4 gives me a real answer, a real number. Under root of minus 4 does not give me a real number, it gives me a non-real number. To be more precise here, it gives me an imaginary number, right? Which is why this becomes a condition for non-real roots. Now when we are using a word like non-real roots or zeros, another terminology that you can use here is imaginary roots, complex roots. So just to revise it finally, what is the condition for real roots? The condition for real roots is delta should be equal to 0 or greater. At the same time you can say it can be greater than 0 and greater than 0. Now when we are saying delta is equal to 0, in that case you are having equal real roots or equal real zeros. Now when you are having delta greater than 0, in that case you are having unequal real roots or unequal real zeros. But the moment you have the value of delta as less than 0, in that case we don't talk about equal or unequal roots, as I talked about few minutes back. We only talk about the roots being non-real or imaginary or complex. We'll further talk about the role of delta in our other videos. If you feel that this video is really informative and knowledgeable, and it will definitely help you to factorize, find the square of a quadratic expression, or factorize or find out the zeros of a quadratic equation, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all, so that you get regular updates from us. If you want us to do videos on specific topics or difficult topics, put it in the comments section so that we can do it for you. Thank you so much. Until next we meet, goodbye.